Mm-hmm. I think I still have brothers coming in, so let me do like this, and I'll just do it from here. Okay, so you guys should be able to see that, and I'll use this for my own. Yeah. So for right now, again, no major announcements. We're just gonna kind of keep going. I think we're in section 1.5. Um, yeah, let's just kind of keep going there for now. I think we're still waiting on a few more brothers to get in, but we'll address that as time arises and as these things come. Okay. So, come on. What's going on? Oh, you need to be restarted. That's right. I forgot you like to do that. At 5 p.m. Okay, this looks good. I think it's fine. Hopefully, it displayed properly here. Let me see what it looks like. Hopefully, my other streams, but I'm not gonna worry about those. Yeah. Can I hear it? Oh wow, that's a pretty good. It's not too bad a delay. Anyway, okay. So if we keep going, so we're continuing section 1.5 with transformations of functions, right? And so we have this guy. So we're asked to sketch the graph of the function, right? We have this basic function. Keep in mind, I am monitoring the chat. Oh, it says the sharing is paused. Okay. Okay, let me see if I hop over to the waiting room. Waiting room. Yes, click here. This one. Okay. And then I always forget that. The very last second. Okay, and then so like this. Let's show the chat. Go one more time. All right, I think we're golden. Okay. Right. So we want to list out the transformations on the functions, right? So we have. Ooh, is this still slowing down? It's a little bit choppy. Let's just reboot it. So yeah, I hope everyone had a good. Well, it's Tuesday, so usually we do the weekend updates on Monday. But we're rapidly approaching the halfway mark, right? This whole experience, it goes by in the blink of an eye. And these, believe it or not, this whole college thing, these are actually simpler times. Like when you get out in the world, it's just you in the world. Like it's not, unless you kind of get in a certain way, it can be kind of, it's basically whatever you make it out to be. You know. Thank you. I am not gonna lock it for right now. It seems to be okay. Okay, so yeah, for right now, so for going forward, we'll just use the PMI link, so that should be fine. The waiting room seems like it's doing okay. I can kind of filter as needed. We'll adjust as needed. Just look like this. Mr. Robinson. Okay. So that I don't stream sensitive information. Let's go like this. Let's switch it back to the waiting room. Which one is the waiting room? I always forget. And I still click on the wrong thing there. Nope. That was these two. Back here. Yeah. Okay, we're good. Okay, this all looks good. Okay. So let's list out the transformations that are going on here, right? We have the square root of x, and you're still kind of slowing down. Let's go like this. This one now should be back to normal. So we have the square root of x, right? So that's going to, the square root of x, the general form of that is going to be like the top half of a sideways parabola. So we have two transformations going on here, right? We have this +2 on the inside and this -3 on the outside, right? So what do you think? If we do an inside manipulation, does that cause a vertical change or a horizontal change? All right. I'll be kind of lax, Mr. McAllister. Horizontal. Hang tight, McAllister. So like this back and hop over here. Okay, let's see if that makes it run a little faster. Okay. And then not right to. Okay. So the other thing I like the, what is it called? Initiative. But we got this +2 on the inside. Now the inside typically is the reverse of our intuition, right? So I know the positive x is in the right direction, but this actually should move. Yeah, this should move left by 2 and then down by 3, right? So the down 3 is good, but the inside is typically the reverse of our intuition, right? So look at the graphs. Here's the original top half of a sideways parabola. We said left by a factor 2. Inside is the reverse of our intuition, and then we go down by 3. No, it's no worries. Look, I messed it up. I got it on video. I made a mistake, and I didn't realize until I looked at the graph. I was like, dang. I had the right thought process, but I applied it incorrectly. So, but the repetition, it eventually sinks in. So then reflecting about the x-axis, right? So if we have our basic function and we multiply the outside by a negative, outside manipulations typically cause a vertical change, right? So if we multiply the outside by a negative, it's going to cause a vertical change. And this is like basically our y's go from positive to negative y, right? The x values stay the same, so then it's actually going to flip over the x-axis. So multiplying the outside by a negative causes a vertical flip over the x-axis. Multiplying the inside, we haven't gotten there yet. So here's our basic function, or our function, whatever it is. If we multiply the outside by a negative, it flipped it vertically over the x-axis. Okay. So then here, say we multiply the inside of our basic function by a negative, right? Again, inside manipulations typically cause a horizontal change, right? So then this one should flip horizontally over the y-axis. We multiply the inside by a negative, it's going to flip over the y-axis. So here's our function. We multiply the inside by a negative, and it flipped horizontally. What is that? Is that cold? That's a cold place. Anyway. Okay. So here we have several transformations going on. All right. What's the basic function? What letter of the alphabet does this look like? Does this look like an S, a W, an A, an L, a V, a U, a 3? Absolute value of x, right? What letter of the alphabet does that look like? A V, right? So the basic function is absolute value. It looks like a V. We have 3 transformations. Typically, when we do transformations in succession, we work our way from the inside to the out, right? How is this -2, this -2 on the inside? So first of all, this changes on the inside. So is that going to be a horizontal change or a vertical change if we do a -2 on the inside? Is that going to be a vertical change or a horizontal change? No. Right? -2 is going to be horizontal, right? Inside changes cause a horizontal. It's next to the x, so it's going to move along the x-axis, right? I guess that's one way you can look at it. But, so, and then is this going to go to the left or to the right? So it is going to be horizontal. Is it going to go to the left or to the right? It is going to go to the right, right? Even though -2 would be to the left, again, the inside is typically the reverse of our intuition. So this actually goes to the right by 2. So then we multiply the outside by a negative. How does that change the graph? How is that going to affect the graph? We multiplied the outside by a negative. All right, so it's like our y's go from positive to negative. How does that affect the graph? Over the x-axis, right? So this is going to flip vertically. So this says we go what? Right by 2. We start with the v at the vertex, or at the origin. The vertex is at the origin. Then we go right 2, flip vertically over the x-axis, and then what does this plus 3 tell us to do?
Up 3.
Up 3, right? Okay. So again, so here we can see the transformations listed out, right? We started with the absolute value with the vertex at the origin. Then we said we went right 2. So if you trace the vertex, notice now the vertex is 2 to the right. Then we said we flipped it vertically over the x-axis, so that's this one. And then we moved it up by 3, and the red is the final graph. Okay. The red is the final graph. Can I help you? What? You just want some attention. No, you still trying to get those chicken pieces I have. No, you can't. Those are for you later. Can't have them right now. Stop. She is like not giving up. Stop. No. Thank you. Okay. Let's keep it moving. All right. So here, so consider the basic function. What? Okay. You got to figure something out. No, get down. Go. So the basic function here we have absolute value of x. Then with g we want to multiply the outside by a number larger than 1. And then in h we want to multiply the outside by a number between 0 and 1. Right? We want to see how these manipulations affect the graph. Right? So we're going to make a table. Choose some values of x. Let's do this ourselves. Right? So let's make a table. So we can do what? X versus what we have? F of x being the absolute value of x. Then we have what? G of x being 2 times the absolute value of x. And then we have h of x being 1/2 times the absolute value of x. That's right. She's so funny to me. Like, I don't know what she be seeing or hearing. Like, it don't be nothing there. And she always finds something to, like, focus on. I'm like, what are you seeing? Let's go like this. So we're going to choose some values of x and then plug them into each equation. On a random note, I was making my way through. I was watching like Cobra Kai on Netflix. It's okay. It's kind of depressing. I'm like, ugh. It feels weird to me. So let me see. We're gonna choose values of x. So let's choose. Let's go -5. Let me think. 4, 3, 2, 1. That might be too many. Yeah. Let me cut this down some. So I'm gonna get rid of the evens. Right? It's just weird because like in that series, all they think about is what they did in the Karate Kid movies, and like it's been like 30 odd years, and that's all they ever talk about. I'm like, yo, if y'all don't stop talking about this thing, it's so irritating. Let me be consistent. 3 and 5. I think this is okay, right? We just chose some x values. We're going to find the corresponding f, g, and h, right? So absolute value of -5. I know I'm almost there. I'm trying not to spoil it, so I'm gonna just not talk about it for right now because I don't know if anybody else intended to watch it. So I'm just gonna try not to talk about it in case because I just don't want to spoil it for anybody right now. I'm almost there. I got a few more episodes. Absolute value of -5 is 5, 3, 1, 0, 1, 3, 5, right? And We should use some colors. Yeah, let's get some colors going. Blue is a new, so I think let's do blue for this one. Style. This. Okay. I'm a fan of this for G. Because when I think G, I think of this color. Okay. Oh, so then we said 2 times the absolute value of x. So basically multiply all those by 2, so we get 10, 6, 2, 0, 2, 6, 10. What color comes to mind when you see the letter H? What color comes to mind when you see H? Anybody got a color for H?
Purple.
Purple. Okay, we can do purple. Let's go like this. Okay. So then half of the absolute value of x. So this first one, let's just do, I think 2.5 is a little bit easier to see. Then this one is 1.5. I think I took attendance for those guys already. Let me just make sure. If I don't do it now. James and Jones. Let me see. This. Get back, hop this way, and let them in. Okay, I think this is going to be more secure the way I'm doing it. A little bit more secure. And then let's keep going. I mean, and they have some interesting lessons. Like, I mean, I see what they're doing. I mean, honestly, I ain't gonna lie, it is kind of boring to me. But I don't know, it's okay. I'm glad I'm seeing it at least once. I don't know that I would go back and watch it again, but I would watch it at least once, right? And then 2.5. Okay, and we could have left those as fractions. Um, let's keep going. All right. So then, do we want to? We can just use the thing, right? Once I did the evens, I guess the evens would have made more sense. All right. Okay. So then, when we graph it, we get something like this, right? Here's the original absolute value of x. All right. Notice when we multiplied the outside by a number larger than 1, it got larger in a vertical sense, right? We call that a vertical stretch. Um, Mr. Robinson, have you not had access to Alex at all? Because if you've already had access to Alex, you want to use the account that you already had. Just let me know. Just let me know. We'll have some time today to kind of put all that kind of stuff in order. Let me finish this and then we'll talk about that. So if we multiply the outside by a number larger than 1, it calls a vertical stretch. All right. So it's like basically the x value stayed the same, but the y values got doubled. So it got bigger in a vertical sense. We call that a vertical stretch. But then if we multiply the outside by a number between 0 and 1, then that's going to cause a vertical shrink or compression. All right. Okay. So again, here we multiply by the outside by a number larger than 1. It causes a vertical stretch, basically by multiplying the y coordinates by 2. We multiply the outside by a number between 0 and 1. This causes a vertical shrink or compression. And it's like basically all the y values get cut in half. Right? Okay. So then let me make a note. So we'll do this like this. I'm gonna give it a go and see how this goes. We're gonna say today Tuesday. Today, September 22nd. Okay, and then we're gonna say start here. Thursday, September 24. Okay. This, add a page. Okay. So, let me start by, let me go ahead and share this, right? And I'm going to check in with each student. Let's go to box. This one, this one, this one, the notes. Export here. So before, first, does anybody have any specific questions, like over the homework or anything with Alex? Um, if you need, like, if you already had an Alex code, really, you really want to keep working wherever you left off. If you don't have an Alex account, then just email me now and I'll forward you the access code. Number 3 in Pearson. What section? Ooh, what section? From week 6? Okay. Give me just a moment. Okay. So what we're gonna do? Ouch. Let's go back. Let's just do a blank sheet. I guess we can use this one. We never wrote anything, so we'll use this one. I need you to kick over though. There you go. Okay, that looks better. So then, so yeah, I do better with like specific questions, right? Like if it's general, then it don't really. I do better just like if you say, okay, can you help me with this homework question? Then I'll walk you through the question. I do better with that kind of thing. Let me pull up. Also, as we work through the homework, make use of the ask my instructor. It'll send me a screenshot. It'll give me everything I need to do, and I make dedicated YouTube videos walking us through. If you sent me an email or something like that, now is actually a good time to kind of straighten it out and make sure that you get your questions answered. But right now, I'm going to go ahead and open up. Let me go to Pearson. Yeah, I need to get outside. Maybe I'll join. I want somebody. I'm going to do like some kickboxing. That sounds like fun. I think there might be something nearby. I ain't gonna lie though, like Cobra Kai actually got me wanting to train again. Like I actually do train. It's been a minute though. I've been out of it. Like I just been like in my own little cocoon or whatever. But I got the urge. I was like, oh man, I feel like let's go do some P90X or let's go for 5 or 10 mile run, something like that. Let's get out there and do something. Like I could feel it again. I was like, oh okay. But yeah, we'll see what happens. That's what I did like about it though. It did kind of make me want to get back out there and just do something. There was a request on number. Let's open up the chat again. Do it one more time. 6. Okay. So I know y'all can't see it. I'll probably load a copy. Let me open it up first though. So week 6 and number 6. Okay. So then what I'm gonna do? Maximize this. Come on. Maximize. All right. So okay, I'll come back to that. Let me stop sharing. and then let me share. We can do the desktop, right? That'll be fine. Close this out. I just want this kind of like over to the side, out of the way. I'll just close it for now. All right. All right. So, yeah. Let me see if there's a way. There is a way. Let's go here. So then what I'm going to do is I think I did like this, and we can hide that. Okay. Give me a moment. I don't like that. So let's hop back to this one, and I'll include what I need to. I'm not going to worry about that. Okay. So it says use transformations of this to graph the function, right? Okay, so this is what we just talked about, right? So we did +5, right? The basic function here is a v, right? The absolute value of x. There's a +5 on the inside, so our intuition might say, oh, that's going to go in a positive direction, which is to the right. But inside manipulations typically are the reverse of our intuition. So this one actually goes to the left by 5 units. So we're going to follow the vertex. The only one where the vertex moves to the left by 5 is C. So then it's just going to be C. All right. Okay. Let's go here and let's do the chat. Oh, number 3. I did number 6. Okay, let's go to number 3. Because that's not the one he requested. Let's go to number 3. Number 3. Describe how the graph of the function can be obtained from one of the basics. So the basic function here is the reciprocal function. So start with the graph of y equals 1 over x. So this is the basic function. That's called the reciprocal function. And then, so we basically said the outside multiplied by 11, right? If we multiply the outside of the function by 11, it'll look like this. So it's larger than 1, so it's going to stretch vertically by multiplying each y value by 11. All right? Hopefully that made sense. Yeah. Let me look at the chat. Yeah, just again, I do better with like specific questions. Let's do 4, 7, 9, and 12. I think we just did number 3 because I know you requested number 3 originally, so we did 3. Let's do 4, 7, 9, and 12. 4, 7, 9, and 12. Okay. So then number 4. She always looks guilty. Graph this function. Okay. So the basic function here is a quadratic, right? It's x squared. Then it's basically just a regular parabola, but then we move it down by 10, right? So I'm going to click here to enlarge. It's a U-shaped graph. So we know the vertex is, can we click the graph to plot the point? Let me see. The first point should be 0, -10, right? So right there, I'm going to click. Oh. Use the given interactions to edit. How do I edit? I want to edit. That's not what I clicked on. Click a plane. Oh, here it is. Oh, okay. So this one's using transformations, right? So we just moved it. We didn't flip or anything like that. We didn't do any stretch. We did a vertical shift. We went down by 10, right? So I'm just going to put in -10. Can I just see that change? Maybe I hit enter. Yeah, that's what we want, right? All this one was doing was a regular parabola. We just moved it down by 10, and that was it. I'm going to hit save. All right. And check. Okay. 4, I think 7 was another one. So let's go ahead and do 7. 7. Okay, graph the function by starting with one of the basic functions and then using the transformations, right? So the basic function here is a parabola, and this says basically the parabola moves right 3 and up by 2. All right 3, up by 2. So all I'm going to do, click on the parabola tool. I'm just going to click anywhere for right now. Okay. We said right 3, so we didn't stretch. We went to the right by 3, and we said we went up by 2. All right, I think that was it. Right, those are the only 2 changes. Okay, I'm gonna hit save and check. Did we not do it right? What does that mean? Check the answer. Okay. I can't remember. Let's go like this. Chat. Did we do 7? Let's do 9 and 12. So number 9. Okay, so the basic function is a parabola. We have 1, 2, 3, 4 different transformations going on here, right? We have 4 transformations going on. What is this? Oh, in the chat. We'll get to the chat in a moment. So we have 4 different transformations. What is this? Ooh. Interesting. But no, not right now. Okay, let's do this. I'm going to try something a little different. All right, we're going to give it a go. See how it goes. Mr. Moore. Mr. Moore, you there? Can you, let me see. Let me give you a chance to unmute yourself. Let's go to Skirty. Yeah, Mr. Moore, you there? You might have to unmute yourself. Okay. So, does anybody want to attempt this one? Anybody feel like they can handle this one? We got 4 transformations. Who wants to give it a go? Come on, guys. I know you can do it. Don't be afraid. It's okay. Anybody? You guys there? Can you hear me? Y'all don't want to try? You scared? Oh, come on. You can't be scared. There's nothing to be afraid of. There's nothing's going to happen. Oh. All right.
All right, so I have a question.
Wait. Is it about this one or a different one?
It's about this one.
Go ahead.
So basically, you just go and plug in -3 times that by 3.
Okay, so we're gonna start with a parabola, right? Let me see if I can get a volunteer. Let me try to get a volunteer. Not you, Malachi. I know you want to volunteer, but you're not part of this class. Get down. Ow! All right. What? No, you're not getting the chicken. Stop.
I got like, I'm not gonna say an educated guess, but I think I know what I'm doing.
Okay, so Mr. Rance, let's give it a go. Mr. Rance, you want to give it a go, right?
Sure. Was someone else supposed to go?
Who else? Somebody else wanted to try other than Mr. Rance?
Mr. Rance,
Who feel it? Who wants it? Okay, Mr. Rance, we're gonna try you, right? So, all right, Mr. Rance. Let me see. We're gonna try something. We're gonna see how this goes. All right. So, Mr. Rance, you now have control of the mouse. Let me see. Wait a minute. Open preferences. How do I'll give you permission to do that?
Oh.
Hang on. Is it allowed? Hang on.
Yeah, I can use the mouse.
Wait. What is this? Zoom. Let's see if I go like this. Let me do this for a second. Let me go like this. Let me hop back over here. Let me do it like this. This is this. I think that's what it is. Let's try it again. We're gonna click this, and then we're gonna put it back. That's fine. We're gonna close this out. Now let's share it again. This is fine for now. I think it's okay. Let's share. All right. So, Mr. Rant. So, what I'm gonna do, I'm gonna give you control, and I want you to do this one. All right.
Okay.
So, I think you can do it.
Yeah.
So now, yeah, just try to see if you can navigate and see if you can do this one. So so go ahead and do click to enlarge.
Yeah, it's not letting me. It's not enlarging. Oh.
I think it's just kind of slow.
Okay.
So then the parabola tool. Okay. Okay. Wait. Let me see. Go ahead and do what you think you need to do, and I'm gonna kind of. Can you think out loud for us, like while you do it? Can you walk us through it?
While I do it, okay. Well, it's a parabola.
Hmm.
So, uh, it's being shifted to the left 3. It's going down 4, and it's reflected over the x vertically by 3, I think.
So let's follow the vertex, right? The vertex starts at the origin. You said what? Left 3 and down 4. So you can click for the vertex. If we go left 3 and down 4, that looks good. So that's the first point. Then we said, I think you did say it flips over the x, so it is gonna open down. So we need to find 2 more points. So hang tight. So now, for instance, when x is 1, right? When x is 1, can you tell me the corresponding y?
When x is 1.
Oh, I was trying to get you not to click. So hang tight. Just hang tight. Wait, don't click just yet. So when x is 1, right? What's our corresponding y? Sorry, not 1, but when x is -1.
1.
How did you get 1?
Because it goes up by 1, right? Isn't that it?
Hang on. Can I undo this? Can we edit this? Let me clear. Let's go back. Okay. So let's go back. Try it again. Go back. Click on the parabola tool. I think it might not have clicked. So just try to click it. Okay. So now let's do the vertex. You said the vertex was -3, -4. Okay, that looks good. So click once. Okay, now just wait. So now when x is -1, if we plug in -1, so -1 plus 3 is 2. 2 squared is 4. 4 times 3 is going to be a -12 in this case. So that's going off the chart, right? So instead of doing x is -1, let's do when x is -2. When x is -2, what is that? 1 squared is 1. 1 times -3 is -3. -3 minus 4 is -7. So when x is -2, y is -7. So we're going to put a second point at -2, -7. Does that make sense?
Yes.
-2. Okay, so click there. We might be done, right? Because we're using the axis of symmetry. So we did the vertex and we did a second point. Let's hit save. Okay, let's check the answer.
Is it on the graph?
You did it. That was awesome. Okay. It's a little creepy having you control my computer. Hang on.
You do a similar question to that because I really didn't understand it. To be honest.
Yeah, I'm still kind of lost.
All right, let's do another one. You want to do the same one or a different type?
Same one.
Let's do a different type first. Let's do a different type, and we'll kind of ping pong between the two. Okay, who else wants to give it a go? So we have Mr. Rance do it. Who else would like to try it? Okay, so let's look at this one, right? The basic function here, or actually this one isn't the same kind of deal, right? It's just choosing. So let's kind of walk through this one, and we'll go back to the other one. So the basic function here is absolute value of x, right? So if we follow the v, now we have what? 1, 2, we have 3 transformations going on here. The first one, we work our way from the inside to the out, right? So we know the basic function is a v, right? And then what does this -4 on the inside tell us to do? What is this?
Go right 4.
This says to go right by 4. Then if we multiply the outside by a negative, what does that tell us to do?
Reflect.
over which axis?
Y.
Oh, it's the x-axis,
No,
right?
X.
So the negative is on the outside. So that's like basically the y's are going from positive to negative. It's like multiplying each y by a negative, right? So this says go to the right by 4, flip vertically over the x, and then go. What does this tell us to do? This minus 2.
That's the y-intercept.
Mm-mm. Uh,
Oh.
in this case, what is it telling us to do though? It
It
also
goes down.
go down by 2, right? It might. I don't think it's going to be the y-intercept in this case. Let me see. But it's basically saying go down by 2, right? So we have a v. The v says go right 4, flip vertically, and then go down by 2. So let's see. Right 4, flip vertically, and down by 2. Is that this one? Wait a minute. That's too far. Right 4 and down by 2. So it has to be either A or C because those are the only ones that's where it flipped vertically. And then it says right 4 and down 2. So I'm going to go C, right? Let's go C. Okay. Let's go back to the previous one. Let's do a similar one for the previous. What's the time? Okay. So let's do a similar question. Let me do this one. So again, basic function here is a parabola. It's a U-shaped curve. We have 1, 2, 3, 4 transformations going on, right? We're starting here. Notice this minus 4 is inside our basic function. So this has to go right by 4. Then it says to stretch vertically by a factor of 3. So we're going to do a vertical stretch. It's going to get tall and skinny. Then multiplying the outside by a negative is going to flip it vertically. And subtracting a positive on the outside is going to move it down by 5, right? So I know I'm not writing, I'm just kind of saying them. I think if I wrote it might help. So again, we're doing a parabola. If we follow the vertex, right? It says the vertex if we go right 4 and down by 5. So 4, negative 5, right? So there's our vertex. So then we can use the axis of symmetry. So we need just, for right now, we just need one more point. Notice the parabola is going to be opening downward because the leading coefficient is negative. Okay. Okay, let's do when x is negative 3. Let me think about it. Okay. Oh, not negative 3, sorry. When x is 3, positive 3, right? So if x is 3, 3 minus 4, can I move my cursor? Will it let me? Okay. When x is 3, 3 minus 4 is negative 1. Negative 1 squared is going to be positive 1. Positive 1 times negative 3 is negative 3. Negative 3 minus 5 is negative 8. So when x is 3, we should be at negative 8. All right, and it's basically using the axis of symmetry. So if we go one to the left, we're at negative 8. If we go one to the right, we're also at negative 8, right? So it's basically using symmetry to generate this graph. So then we're going to hit save. And check the answer. Okay. Let me see. That was 9. Let's try number 12. All right, we just kind of got to keep ping-ponging. Let's try number 12. Number 12. Okay. Write the function whose graph is this, but it's shifted left by 5 units. So that means we need to, if we want to shift this graph to the left by 5 units, what change do we need to make? What's the change? So what's going to cause it to shift to the left by 5?
Plus 5.
Plus 5, right? So let's do plus 5 on the inside. I think that's it. Okay. Let's do, we did 3 already. Let's do 8. Why was 6 afraid of 7? Because 7, 8, 9. Oh, why did I say it? Let's do number 8. What time is it? I'm totally just geek because I'm about to get off of this stuff. Okay. Graph this function using transformations. Basic function right here is a cubic function, so it's like that S shape, right? So we have two transformations going on. We multiplied the outside by a negative, so that's going to flip it what vertically. It's like the y's go from positive to negative. Then it says to move up by 2. All right. So all we do is this is going to have this general shape. So I'm just going to click. Okay. So then I just click. So now we're going to apply the transformations. We said flip it vertically. So reflect over the x. And then move it up vertical shift by a factor of 2. All right. And that's it. I'm going to hit save and check the answer. Okay. Go ahead. So let's look at the chat. We just did number 8. Let's go ahead and do 11. Since it was requested, it probably won't take that long. Let's go here. What's the time? Numero 11 is this one. Okay, so this is called a stepwise function. Okay, so this is generally how the graph looks. It's like these. This looks like the steps of a staircase. So now, we just need to account for these transformations. We start with the general function. Okay, the innermost says to go right 3 and then stretch vertically by a factor of 2. Let me think about it. Greatest integer. So normally it would start at 0. So we'll just choose a few points, right? We'll choose some x's, find the corresponding y. But we're anticipating it to go right 3 and stretch vertically by a factor of 2. All right. Does any of these look like it went right 3? So it should. I'm thinking what, B, right? B, I think, is the one that looks like it went right 3 and was stretched vertically by 2. This dog makes me so nervous. She be pacing. I mean, when she paces, I think that she has to use the restroom. And I feel like if I don't let her out and she messes in the house, I can't be mad at her because I didn't let her out. But I'd be mad at her. So, you know. I just need to be more responsible. Okay. So let's see if this one works, right? For instance, we're saying, what is this? 1, 2, 3. So let's do like if x is 3.5, right? Can I blow this one up? So if x is 3.5, 1, 2, 3.5, this says that it's 0. If we come over to ours, 3.5 minus 3 is a half. A half is between 0 and 1, so that collapses to 0, so the answer should be 0. So that looks right, right? When x is 1, 2, 3. When x is 3, the answer should be 3. The answer should be 0, right? And it is. Let's do when x is 2, right? When x is 2, 2 minus 3 is negative 1. The greatest integer less than or equal to negative 1 is negative 1. Negative 1 times 2 is negative 2, right? This one checks out. Let's do a fraction or a decimal. When x is, let's do 2.5. When x is 2.5, the answer should be negative 2. If we plug in 2.5, we get a negative 1/2. The greatest integer less than or equal to a negative 1/2 to the left is going to be negative 1. Negative 1 times 2 is still negative 2, right? I'm gonna go with this one. I think we chose B, right? I'm going to check that answer. I just chose a few x values, found the points. Another easy point to test is the origin, right? When x is 0. If we plug in x is 0, that's going to be a negative 3. The greatest integer less than or equal to negative 3 is negative 3. And then 2 times negative 3 is going to be negative 6, right? Notice when x is 0, negative 6 goes off the charts. So it's down here somewhere. All of these others have essentially values for 0, but it's not negative 6, right? So B is very promising. I'm going to check that answer. We're good to go. So again, greatest integer, whenever we have an x value between two integers, we take the integer to the left, right? If we did 2.5, the greatest integer less than or equal to 2.5 is 2. If we did negative 0.75, the greatest integer less than or equal to negative 0.75, the integer to the left is negative 1, right? If we get an integer, we take that integer itself, right? And that's kind of how the greatest integer function goes. We got time for a few more. I just kind of unmute yourself, or if you have questions. That was number 11. I think that one was good. I know that one would trip students up. Number 14. Let's look at number 14. Anybody know that movie reference that I'm doing when I say the numbers like that? If I say number two, murdering, he kept calling his henchman number two. It's a comedy. Curious if anybody knows that one. Okay. Uh, let's see. Write an equation of a function. It says the graph of this is shifted 3 units left, stretched vertically by a factor of 5, reflected over the y, and shifted 6 units up. Okay. So we have our basic functions. Now, whenever it's side to side, that means it's inside the basic function. If it's not side to side, if it's outside, that means it's gonna. If it's vertical, that means it's gonna be outside our function, right? You got some interesting sounds going on there, Miss Missy. Now this says 3 units to the left. So what we're gonna do is do. I'm gonna have to check that in a moment. 3 units to the left. We say plus 3 on the inside. Okay, let's do this, right? So the original function was x cubed, right? So now let's account for these changes. It says 3 units to the left, so that means we need to do a plus 3 on the inside of the basic function. Stretch vertically, so since it's vertical now, we need to be on the outside by a factor of 5, so we're going to multiply the outside by 5. Reflected in the y-axis, so that means we reflected side to side, so we need to multiply. I think we need to do something like this. All of the inside, here, let's just simplify it. So all of the inside by a negative, right? We distributed the negative on the inside. So that'll flip it horizontally. And then shift it up 6 units. So we're going to say a plus 6 on the outside over here. Plus 6. Okay, let's see if this works. If this doesn't, I have an alternative. Okay. Only alternative I can see, there's a couple. Let me try like this. Put this in parentheses. We said we went left 3 units. So we're going to put this back as a plus 3. And I'm going to do a double set of parentheses like this. So before what I did was distribute, but I think this might be okay. We could actually factor out that negative. Let me see if it accepts this one. Hang on. We can actually factor out that negative because a negative cubed is still going to be negative. So that negative can actually go here. And let's try this. Maybe this will get it. I can't see anything else. Let me see. Correct answer. Oh, that's how they captured it. Okay, so we had the right idea. We just weren't using it properly, right? We had the negative in another position. Okay, let's do a similar one, right? Because we just weren't positioning that negative properly. So let's just do it again. So again, we're going to start with the basic function, which is this x to the power of 3. So now, 2 units to the left, so we're going to say plus 2. That moves it to the left by 2. Stretch vertically by a factor of 5. So that means the 5 is on the outside, reflected on the y. So what they did, the negative does need to be with the x, so we're going to rewrite this as 2 minus x. Okay, so that seems to be how they're capturing it, which is fine. And then shift it 4 units up, so that 4 needs to be on the outside, right here. Right? And that's how it goes, right? You do it, you get it wrong, you find out why you got it wrong, you adjust, and then you do it again. You know, and that's how it goes. Okay. We got time for a little bit. Oh, what did I hit? Did it go away? No. Okay, that's okay because we're still working. So let's go like this.
Are you gonna upload this recording to your YouTube?
Yeah, I think it's streaming.
Okay.
It is streaming, right? So all of this is there. Let's see. I think we just did number 14, right? Yeah, it is on YouTube. Yeah, this is good. If y'all want, we could do one more. If not, we can call it a day. I think we're okay. All right. Let me do like. Let me actually just go here. Oh shoot! So the thing I just realized about YouTube though, with these are all going to be audible because I wasn't showing those screens. I was only showing my iPad screen, and I never wrote on my iPad. So It's just going to be the audio, right? So that's kind of how that's going to go for today. Okay, guys. If there aren't any other burning questions, we'll pick this back up on Thursday. We're just going to keep going with section 1.5. Again, on a weekly basis. So we want to be sure to be completing about. Everybody needs to be doing at least 25 topics a week on Alex. If we have class time, you can actually take the class time to work on Alex a lot of times. I want to use that all the extra time that we have to just answer questions, homework questions, Alex questions, anything related to our subject. Let's go ahead and just knock it out. We can work on it together, right? And then that way, when we get out of class, hopefully you would have done enough so that you don't have to. You can the rest of the time is your own, right? So class time to me is especially because that's the way we're doing it, is the best time to get the stuff done. If there aren't any other burning questions, guys, you've been awesome. Take care. I'll see you next time. All right. Take care. All right, we're gonna stop this. Yeah. Let me let that sit.